Hey guys, it's Rich Price here from Gloucestershire College. We're going to do a quick video today about BIM, Building Information Modelling, so take a look. Cheers. Quick video today thinking about what is BIM or Building Information Modelling. Okay, so we're just going to sort of cover some of the essentials here today and think about what is BIM and how it affects the industry. So building information modelling is a term that's been sort of chucked around the industry for the last few years. In particular, it does date back sort of further as a concept, but you know, now everyone's talking about BIM, everyone's talking about building information modelling. So generally, it's thought of as 3D CAD or 3D design, which really only covers a small part of it. I mean, that certainly is a part of building information modelling, the idea that we want to be sort of drawing our designs up in 3D and building digital representations of the project rather than our traditional two-dimensional CAD. But there is more to it than that. So building information modelling, covering the sort of essentials and basics, it's the idea that yes, we design and start to build our design up in a 3D program, okay? But it's also the idea that we share information more effectively between different disciplines and different companies and different subcontractors, etc. within a project. And it's the idea that we share our 3D design with each other, so we do what we call federating or coordinating models. So somebody, you know, with the architectural 3D model will have a 3D representation of that, and they will send it to the structural person who will integrate their 3D model based around, you know, and work out that those two things are going to fit together, and then those people will share, you know, their 3D information with the MEP guys, the people designing the plumbing, the electrical sort of works, mechanical stuff, the ducting and that stuff, and that will be designed in 3D, and you'll be able to federate those models together, so it makes one big sort of digital representation of the project. The idea is that all of this information is stored on what's called a common data environment, so a common place where all this information and digital representation is stored sort of in a cloud, in a common data environment where everybody on the project has access to it, where they can, you know, they can take what they need from that to base their design around other people's design, basically, so that you're clash detecting, you're federating, you're looking at someone else's 3D representation and seeing how that interacts with your design. BIM, Building Information Modelling, is about not just drawing in 3D, but attaching information to your design. So it's about having all that information in one place. So you've got your 3D drawing, your 3D model, say for example a smoke detector, and you're attaching information to that 3D representation, so that when somebody looks at that smoke detector in a project and say clicks on it, it's going to generate a whole load of information about that smoke detector. It's going to tell you things about its spatial sort of representation, the size of it. It's going to tell you about the materials involved with it. It's going to tell you about where it is in the project. You know, is it fixed on that particular detector? Is fixed on level 2, level 3. It can give you information about where it is in the building with regards to which room it's in, a room reference. It can give you information with regards to cost. It can give you information with regards to maintenance. It can give you information about when that thing needs to be checked or serviced. It will give you all this information. So, I mean, the idea of BIM, one of the main features of it is to improve operations and maintenance, to make buildings more effective in the long run. All the while, when we're thinking about the 3D sort of design, you still need to be able to generate your regular 2D information from that for people to read, whether that's engineers installing things or whatever. So these programs generally, I personally work with Revit. There are other BIM softwares out there, but you can take sections and slices to create floor plans and your regular building sections at any point through the project, and it will generate your regular 2D imagery that you can use to send out, like I say, to engineers or anyone who still needs that 2D information. But it's important that the 2D drawings have to be generated from the 3D model, so it's not the other way around. A lot of people are doing it the other way around, you know. They think they're doing BIM, but they're not necessarily doing it properly. So they're starting with a 2D design, like they regularly would, and then they're going through the hassle of generating a 3D model after that, you know, because that's what the client's asking for. People are asking for the design in 3D now. So it's like they're doing the work twice. You know, they're starting with the 2D stuff like they would anyway. They're doing the whole process of what they would usually do anyway, and designing in 2D CAD, AutoCAD, or something like that. And then they're getting someone to build some sort of 3D representation alongside to send off to people, which isn't strictly BIM. Really, you should be building the model from scratch, and then the model is then generating that 2D data automatically. You can take the slices through the building horizontally, vertical. Likewise, you know, BIM is the idea of generating schedules and generating costing sheets and estimations from the 3D model, whereas a lot of companies, small to medium enterprises, will still be doing it the old school way. They'll be designing in 2D, then they'll be doing the takeoffs, and then they'll be generating costing and that kind of thing the old school way, and they'll be building the 3D model on the side to hand over to clients to show that they've got those capabilities, which, you know, is great. But it's not strictly speaking BIM. Really, you should be building the model up in 3D, and as you're attaching intelligent information to the different elements of the model, a smoke detector, a door, a floor, a wall, a window, you're attaching that information to it. Revit and other like softwares, BIM softwares, will be generating the schedules. As you're attaching information about when that thing's going to be installed, you know, a date, a time, what phase of construction it's going in, you can actually generate the schedule, the program of works as you're going. You can generate the costing as you're going. And so you should be producing that information as you're building the model. So if you're doing it properly and correctly, then actually you're going to be saving an awful lot of time. You're not going to be doing takeoffs. You're not going to be producing piles and piles of paper, of 2D drawings, of schedules, of costing.
Okay, so sorry, my battery ran out on my camera. That's why it ended a little bit abruptly. Just take a little look at some of the things we were talking about. I thought we'd take a little look at Revit. So, you know, that's the BIM software I use. If we take a little look at this model here, forgive me, my computer is not really great, so it takes a little while to load these kind of things, which is why there's all the jumping and bits disappearing there as I move it. But let's take the concept of this model here. So this is the external architectural model, and if I show you here, this particular project that I was working on is made up of lots of different files that I need to integrate. So the one we've got open is actually just this one here, the external architecture, but there's lots of other models to integrate into the project. Ground slab piling, internal compartments, so that's sort of the internal architectural features, 3 different MEP models, and 2 structural models. So, you know, as someone who works mainly in MEP, I would, you know, I would need to receive all these models really to start basing my design around. If I'm designing a small part of the building, say just the fire and security, so access control, smoke alarms, CCTV cameras, okay, then I need to be able to see all these other things, you know, to base my design around. And that can be a problem because, like I say, so you've got these big 3 MEP models here, and I was working for a sort of small company, so I'm quite far down the chain. So I need, you know, I need to request from a larger MEP company than me the Revit files. And, you know, what was happening was with multiple different companies, they weren't sending everything they were supposed to send. So I'd be opening up, you know, a file like this and maybe say, well, you know, because I know a little bit about construction, don't I need a structural model as well? And they'd be like, okay, yeah, of course, yeah, let me send you that. And you'd start basing your design and making your design. And sometimes you would just notice that things don't feel quite right. It feels like something's missing. So there might be devices from the MEP model, like a manual call point or something like that, just sort of floating in the air, and you think, you've got to now try and work out, is that because there's something missing structurally that the manual call point or device is supposed to be attached to, or is it the fault of the person designing that electrical system who's moved a device somewhere by accident and forgotten that it's there and it's just sort of floating. So when you come into that kind of problem, that's what you need to do is then pick up the phone and call the different companies and try and find out what's going on. And in this case, it was frustrating because they'd sent me one structural model, and I started basing my design, and I started noticing that something just wasn't working. And it turns out there was another steel structural model that they hadn't sent me. So when they finally send this, I integrate it into my model, and there it appears, and that affects my design, where I'm going to position things. And that's frustrating because that's not essentially my fault. It's really their job to send me all the files I need, all the information I need, because as the 2D drawings are being generated from the model, if I don't have that second steel model in place, then they're not going to appear on my 2D drawings, because Revit is generating the 2D information from the model. It's literally a slice through the project. So if I change something in the 3D model, it changes something in the 2D drawing. They're one of the same. And if something is missing from the 3D model, then it's going to be missing from my 2D drawing. So that's some of the sort of kind of issues you've got. So we're going to go ahead and try and federate a model now and start adding some files in. Now, because my computer's not so great, I'm just going to add one MEP model and one steel model to demonstrate how you sort of federate the different disciplines and how you add them together and what that looks like. But obviously, if I was working on this live project, I would need a more powerful computer, and I would have to add all these files together. Okay, so let's go ahead and do that. Okay, so let's take a look at federating this model, or linking other models into this to make it more sort of collaborative between disciplines. So here we've got the external architectural model. So you can see the sort of curtain walling, the glasswork and the aluminium sort of frame in there. The door and window systems. You've got some roof lighting and all that business. So the external architectural model. If I want to link in that MEP model, in fact, let's start with the structural model. It's really simple to do that. You just go at the top here and you go Insert, and you say Link Revit, and you can see it says links another model to the current model. So you click that, and then you go to wherever that linked model is saved on your computer. So in this case, I'm going to link this MEP. No, we said we'll start with the structural. Why not stick with that? So I'm going to link that steel structural model. Be sure to select the right thing down here, the right option. You need to check with whoever sent you the stuff you're linking, that how they drew it, center to center, origin to origin, by shared coordinates. If you get problems linking your models together, it might be because you haven't selected the correct thing there, so you just need to inquire into which one you need down there. But if I just double click on the steel structural, okay, so there you go. You see that structural stuff, structural model has been brought in and federated alongside my external architectural model. You have to bear with me, my computer is not good, and this is a big old model, so probably wasn't the best example, but you can see there's some pile foundations, some concrete slabs, some foundations, and you can see the steel work now has been sort of integrated into the model. as you can see, when this structural model has been brought in, this steelwork and concrete, you can see it makes sense with the external architectural model. It all seems to fit together nicely. Now that happens because both models have been drawn to the same coordinates, you know, so that they've been sort of drawn so that they will fit together, you know, like you would do in traditional design, obviously. That's not always the way it works out, unfortunately. If there have been issues with coordinating, you know, a certain company coordinating their drawing and sort of getting some of the coordinations wrong when they're making the model, when you load an external model into yours or link it in like we just did, you know, sometimes it's obviously not drawn correctly and it appears, you know, miles away to the left or right or above or below, or sometimes upside down, or you know, on the wrong sort of rotation. And if it's obvious like that, it's okay, because you can spot it straight away and you can see that there's been a problem, and again you need to pick up the phone and call that company and try and work out where the issue is. You know, is it with your model, or if there's two models that you've received that aren't linking up, you know, who's at fault there, and which coordination system is correct, and who needs to adjust their model to fit properly. But you know, sometimes it's more subtle, and someone's drawn something only just, you know, a little bit out of the coordinations, and that's harder to see straight away. So it's more when you start working with the model in depth with the drawings, and you might notice that things just aren't adding up and things just aren't fitting, and there's bits of structure that's poking through, you know, the architectural features and that kind of thing. So you will come into issues with linking these models, but that essentially is the basics of how you do it. It's very straightforward. So why don't we, forgive me, I think I'm going to go with a smaller sort of model example next time, because my computer just really isn't handling it. Why don't we link in an MEP model, a mechanical, electrical and plumbing model. Like I said, there was I have 3 to choose from for this project, but let's go with MEP3. So again, we went up to link, Revit link in the corner there, and it's going to give us the option, you know, pick the thing you want to link in, and I'm just going to double click on MEP3, and it's going to load that into the model. And if it's been drawn correctly to the correct coordinates, then it's going to load in exactly the right place. That, you know, that's the theory. Okay, so that's telling me that MEP model is loaded in. Now I happen to know that this MEP3 model was a small section of the building. I can see it there just to the left, all that sort of work there. So let me just home in on that a second. So I can see that there's a whole bunch of mechanical stuff loaded here, some of it on the roof there. If you find when you're looking at MEP stuff, ducting, pipework and that kind of thing, that there's parts missing, then just make sure you switch your detail level to fine. Like sometimes there might be pipework and that kind of thing not showing. But here you can see there's a whole load of ducting work there, and you can see through this roof light here, you can see a load of mechanical and plumbing parts. So again, if all this is drawn correctly to the correct coordinates, then all of that stuff will be exactly where it should be in relation to the steel work and the architectural work, okay, and vice versa. And so, like I say, in my case, designing the fire and security stuff, now I'm aware of a whole lot of stuff that I can start positioning my detectors, positioning my things to make sure that they avoid these, you know, this duct work, this pipe work, to make sure they don't clash, to make sure that my design isn't going to inflict negatively on somebody else's design. The point of all this being, of course, is that very often when we get to site and somebody's put something you know, in our way that we weren't aware of, part of their design, then we need to change our design on site, and quite often that information needs to get passed back from the engineer or the fitter, whoever's installing the stuff. That information needs to get passed back to the office, and then the design team need to go back and reevaluate and redesign, and then pass that information back down to the fitter. So the idea is that we're really going for clarity in 3D design here. We're really trying to avoid clashes. And you know, while I'm designing my my design, say let's take the smoke detectors, I can set it up so that if I'm placing smoke detectors into a model, that Revit will actually alert me if there's anything in the vicinity of that smoke detector. So often smoke detectors need to be a certain distance away from lighting fittings and away from a wall, like the edge of the perimeter of the room, you know, the wall and that kind of thing. And as I'm designing, as I'm putting them in, I could set it up so that Revit could warn me and say, you know, you're clashing with something. That's the kind of thing that these BIM softwares are capable of. The other thing that we can do, or should be able to do, if we're considering our model to be sort of building information modeling standard, is be able to generate schedules of information about the items and the makeup of the project actually from the model. So as we've been building the model, we should be able to generate schedules of information, of materials, of cost, and all kind of things like that. It should be nice and simple. So if we take this model here, which again we've integrated and federated the external architectural model with a structural model including concrete and steel and a part of the MEP model. So if you want to generate some schedules of information from that, you go to the View tab, you go on to this Create part here, and see this symbol here, and you highlight over it and it says Schedules. So you just go ahead and click that, and it will give you options of sort of what area you're wanting to create a schedule about. So let me try architectural, turn off mechanical. Let's go with curtain wall mullions, so the curtain walling, or curtain systems maybe, or curtain panels. Maybe we could try windows or something like that, you know. Let's try windows. And then you'll be presented with another sort of selection phase where you get to select as much as you want, as many areas as you want Revit to generate within your sort of spreadsheet or schedule. So let's go with assembly code, and you can see it's popped over to the other side, it's popped over to here. If you wanted to remove it, you just click remove and it goes back over to the left, but you can click add like that. Let's go with cost, family, filter material, manufacturer, level, sill height, and I'm just selecting these at random here. It depends what you're after, you know, obviously. Model, door window number. You know, I'm just selecting these at random now. Once you've selected all the desired sort of areas that you want it to generate, you want Revit to generate information about, it's as simple as clicking OK. And look at that, we've got a whole load of information generated there now. You'll see that some of it is blank. Now that is to do with the fact it's your spreadsheet or schedule is only going to be as good as the information that was attached to the individual pieces of the model to start with. So if you break it right down into little components like windows, that's its own individual model in its own right. It was created individually in Revit Family Editor, and it all depends on what information the engineer attached to it at the time. And with BIM you should be attaching everything, as much information as possible. But you can see here that we've got, you know, a lot of information there. So we've got the level that a particular window is on, okay? We've got the model in top hung, bottom hung. We've got a load of information there. Now this spreadsheet is not separate from the model. The point is that this is attached with it. So if I change something in the spreadsheet, it will change it in the 3D model. If I change something in the 3D model now, it will change it in that spreadsheet, that schedule, automatically. We'll try and get a little example of that now. I do appreciate my computer is very slow and it may be hard for us to do that. If I go hidden line, let's select this window here, so you can see that this window is on the ground floor. There. So if I keep scrolling in there, there it is, highlighted. That's the exact window that we're talking about, that is related to this part of the schedule. Oh, I've selected another window now, so you see it unselected that. If I go back and select that, there's my window. Model, top hung, visual light, got information about that. It's on the ground level, as I know. No, I mean, this is a good part here, but a good thing to know is that I can start adding information into the schedule, and it'll attach it to that model there. So, like, I can see if this window for some reason it hasn't got the clear, it hasn't got the glazing information, but it is meant to be clear glazing. I can select that, and now that will be attached to that window. And likewise, you know, I could do it there. If that one below was actually the other option, I can add that, and you can see it's that window right there, down here. Let's take a look at a window on the 3rd floor. No idea where it is in the model, but hopefully Revit should have a little pinpoint. There. There it is. So there's that window that we're dealing with there. So you can see how the schedule of information is actually linked, you know, really linked to that 3D representation model. If I delete that window now and it disappears, it will disappear from the schedule. If I change it to a different glazing kind, then it will change actually its glazing in the model. So yeah, that's sort of how you generate a schedule, and we could do that. You can see how quickly and easily that was done, and we can do that with any element in there. We could do it with the structural steel, we could do it with the lights, we could do it with the toilets, we could do it with all the plumbing, we could do it with the pipe work, you know, the carpeting, anything at all. So you can see how that's, you know, going to save people a lot of time when they would really have to be filling in these schedules manually in Excel. And if you change something in your design, then there's no way it's going to change it in your Excel spreadsheet. They're just not linked that way. Or if somebody changes something in a schedule, an Excel spreadsheet, and they forget to go back and change it in their design, you know, this hopes to remove that issue, basically. The other thing we talked about was generating your 2D data from the model. So with a little bit of sort of knowledge and know-how in the setup process, you know, you can take your 3D model here and generate your floor plans, ceiling plans and sections. If we take a little look, what have we got? Take a look at the plan views, floor plans. So let's just generate the ground floor, and then it should appear down here in the project browser. And there it is there. We've got our floor plan there. And so, you know, you can see your the relevant sort of MEP stuff. You can see your duct work and pipe work. If I change that to fine, should give me a more full picture. You can see some pipe work and ducting work there, and you can see these electrical devices. And the great thing, you know, there's some floor boxes there, I think. We can see there that that's a distribution port floor box. And notice here that we've got, like we find in our traditional 2D drawings, instead of, you know, you've got symbols that represent devices, and we have that here as well. Now, don't be mistaken, these are not just symbols, they are actually attached to the device in the 3D model. You can set up Revit and set up your models so that when they're viewed in a plan view, they will not display what that device looks like from a plan view. They will display the symbol, the industry symbol that's recognizable, So you're producing all your regular 2D data. So look, that that's a light switch there, and it's being shown as the traditional industry sort of expected symbol for a light switch, but that will actually be in the 3D model. We'll be able to click on that light switch, yeah, and delete it, and it will delete it from the model. So if I select something, let's tile here and show you what I mean. If I select something in the floor plan, such as a door, so let's go for that. Where is that in my model? There we go. Where is that door? There it is.
Okay guys, well that was a little introduction to BIM, some of the essentials and a sort of just a rounded, very beginner sort of explanation as to what it is. And there's going to be a lot more to it. There's legislation and all sorts, but that's I suppose in a nutshell, and the fundamentals, and looking at how information is connected to the actual design drawings. Please be sure to check out the other videos on this channel. There's going to be more on BIM, there's going to be more on Revit, and there's going to be other things just on general construction. Okay, cheers, bye.